Okay, in our last video for this day, we are going to learn about the HL congruence postulate, practice with triangles including the triangle congruence statements, and then finally learn why does it not work to have angle side-side or side-side angle. So, the HL congruence postulate is a special case. This is the only time I can have an angle with two sides and that angle not be included is if that angle is a right angle, which means I have a right triangle. So this works for right triangles only, because that's the only time I have a hypotenuse. So right triangles only. Now, it's not every right triangle, because there's other criteria that have to be met. In order to use HL congruence, the H stands for the hypotenuse. So I would need to know that if this is triangle ABC and this is triangle DEF, that the hypotenuses, or hypotenae, I do not know which one is correct, are congruent. The hypotenuse is that side across from your 90-degree angle. So I would need to know that segment AC is congruent to segment DF. That is my hypotenuse here. I would need to know that the hypotenuses are congruent. Secondly, I would need to know that the L, leg, that I have legs that are congruent. Now, the good news is, legs of a right triangle are either of the other two sides. It doesn't matter. So I might be told that segment BC is congruent to segment EF, or that segment AB is congruent to segment DF. Either way, I'd have what I need. So let's call it segment AB congruent to segment DE. Segment AB congruent to segment DE. There's my congruence statement. That is an example of my legs being congruent. The last thing you need is you absolutely must have angles B and E be right angles. So I would need it to be a congruent statement. Angle B is congruent to angle E. But also, right before that, kind of leading into that, is what we would have as our right angle statement. Angle B and angle E are right angles. That means they're congruent. Now I have my three congruent statements: a hypotenuse, a leg, and congruent right angles. That allows me to make my conclusion that triangle ABC is congruent to triangle, well, I know that B and E are congruent, they match up, so E would have to be in the middle because B is. I started with AB, which is my two tick marks, meaning I need to start with DE, so it's triangle DEF. Okay, so we have 5 ways to prove our triangles are congruent. Now, we're going to look at examples here where we're going to want to do 2 things. First, write a congruent statement if it's possible. Then state what method or what congruence we used. Remember our methods. Side angle side congruence, meaning I have the included angle between 2 congruent corresponding sides. Side 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 congruence, meaning all 3 sides of one triangle congruent to all 3 of another. Angle side angle congruence is when I have 2 angles in a side and the side is included. Angle angle side congruence is when I have 2 angles in a side but the side is not included. And then our special case, HL congruence, that means I have congruent right angles giving me a hypotenuse which is congruent, and then any leg. In all of these examples, do not forget, we can always mark reflexive property and vertical angles. That's going to be an important theme in this unit. In number 1, I do see that my 2 triangles share a side. I'm going to mark that congruent. Now, like we did earlier, I'm going to go off to the side here and copy just one of my triangles. So I'm trying to just isolate out this triangle here. This is what the process I'm doing right now. And I look at that triangle, I know I have this marked as a right angle, I have that angle marked congruent, and I have this reflexive property. So I'm trying to decide, is that one of these 5 congruence postulates? If it is, then my triangles can be congruent. If it's not, then I don't have enough information. So I know that this mark down here is an angle. I know that this mark down here is an angle, and I know that this mark on the side here is a side. I have two angles and a side, so it can't be side angle side, it can't be side side side, it could be angle side angle, it could be angle angle side. It can't be HL. Even though I do have right angles, this calls for two sides then. So it's a decision that we have to make if we are doing angle side angle or angle angle side. Well, if it's angle side angle, that means the side that touches both is congruent, and we do not have that. So I can go right away and say these are congruent, and it's by angle angle side congruence. The next part is equally tricky. I have to name my congruent triangles. The first triangle does not matter. You can name it any triangle you want. Okay? In this case, I might name this triangle here on the left first, and I might name it triangle SIM. If I'm going to name it triangle SIM, the key important piece here is the second triangle must be matched up with corresponding parts. I chose angle S first because I have that angle marked congruent. It's going to be easy for me to pick the first letter of my second triangle because it has to be congruent to angle S. That's angle P. So I know S and P match up. I have them first in both triangles. Second, I do have angle A or angle I here in this triangle matches up with the same angle here. That's the same vertex. So I should go segment PI, which means M is last. Now I know that triangle SIM is congruent to triangle PIM by angle angle side congruence. Okay, there's three more of these types of problems that I want you to try. So go ahead, press pause, try to decide if they're congruent, what postulate, and then come up with your congruent statements. When you're done, unpause to check your answers. Okay, so for number 2, the main thing is your triangles may not match up exactly with my triangles as far as their names, but B should be in the same location in both, U should be in the same location as S, and L should be in the same location in both. Whether you have them first, second, or third doesn't matter as long as they match up. And then it is side-side-side congruence because we have 3 congruent sides. We included our reflexive property. In number 3, we add the vertical angles. When I add my vertical angles being congruent and I look off at the diagram on the right or on the left here, I now know that I have 2 sides and an angle. The angle is included because it's made up by my sides. So I have side angle side congruence. Now, naming the triangles. Again, this one was hard. Okay, I chose to start with A, go to M, and then T, naming my first triangle. That meant segment AM was the first part of my name. I needed to match that up with that segment from my other triangle. That's segment DM because they're marked congruent. So your A and D need to be in the exact same location, however you named it. Your M, and your T and E. Again, how you name the first one doesn't matter. I could have chosen to name the first triangle MTA. If I had done that, it would be congruent to triangle M. Well, M to T is the 1 tick mark. It would have been M to E to D. Notice I had M second and second. I just have it first and first. T is now second. It was third. E is second. It's now third. So T and E were second. T and E were third. A and D are last. A and D were first. They're in the same location. That's the major important piece of information when I'm naming my congruent triangles. The last one. These triangles are congruent. Here's a little thing that's the difficult part. This is going to be my HL congruence. I have 2 sides and an angle, but that angle is not included because it's not formed by the 2 sides I'm dealing with, such as example 3 here. but I do have a right angle, hypotenuse, and a leg. Now you ask maybe, why is it that we can't call this angle side-side congruence? Beyond the fact that that would make us write down a word that we're not allowed to write in school, it's inappropriate, it doesn't work. Knowing that it's just any angle with two sides isn't enough information. On our last sheet of paper, we'll see why. Here, I have an angle, a side, and a side. So I'm using my rear end to try to prove these triangles congruent. But it won't work, because if I have this angle locked in, that's this angle here, and I lock in this side here, I can find multiple ways to use this side here, which is my congruent side to segment HD. I could bring it straight down here and say, hey, those are congruent triangles. It works. However, I could take that same side length here and reflect it and form this triangle here, where no longer do I have any of this information. This triangle right here would not be congruent to my original triangle, because there are no rigid motions that I could take this triangle and map it onto here. That's why angle side-side does not work. It doesn't lock everything into place to hold that triangle so rigid motions would map them onto it. It has this kind of what we can call it maybe a hinge with this extra side. I could put it over here to form my triangle. I could put it, now this side is locked, it has to be going in this horizontal because my angle is locked in place. So my two options are there or there. One of them would give me a congruent triangle, one wouldn't. It doesn't work in every case. I have a counter example that proves it doesn't work.